Hey Algebra 2, today we're going to get started on Chapter 1. It's called Equations and Inequalities. This lesson is going to cover 1.1 and we're going to talk about real numbers and number operations. So very much review, but you might want to jot down a couple of notes anyway. So to start out with, subsets of the real numbers. So up to this point, every number we've talked about has been a real number. And so you see, outlined in this big green box here, all of these numbers are all real numbers, everything in here. So we want to know, though, about the subsets. So the smallest subset of real numbers we're going to talk about are our natural numbers. Okay, you can also call them counting numbers. So they start with 1, 2, 3, because when you count, you start with 1, right? Then we add 0 and go up to our whole numbers. Then we're going to add our negatives and go up to integers. So in this green circle here, we have everything from negative infinity to positive infinity, but no decimals or fractions yet. So we are going to go up one more circle to rational numbers, which is going to include our decimals and fractions. And in fact, not just any decimals, but decimals that can be written as fractions. Those are included in this larger blue oval here. But you're probably aware that there are quite a few decimals that you can't write as a fraction, and those are over here in their own spot of irrational numbers. So they are still part of real numbers, okay, but they are not a part of the other ovals. So in our Venn diagram here, there's no overlap between irrational and rational. They're completely separate. Next, I want to mention a couple of parts of the number line, and I know you've all graphed on a number line. It just might have been a couple of months. So first of all, always make sure that you put arrows on the ends of your number lines. Okay, number line goes on forever, so make sure you have arrows. 0 does not have to be in the middle. This one is. It doesn't have to be. But do remember 0 is called your origin. And if you're going to plot let's see here, if I plot a coordinate, okay, that is the graph of 3. So not a very extensive graph compared to a coordinate plane, but that is the graph of 3 there. And 3 would be the coordinate of that point. Next up, we're going to review the properties of addition and multiplication. So anytime you add or multiply, there are properties that you're using, even if you've forgotten that that's what you're doing. First one up is the closure property. And the closure property really is just that the type of number you begin with is the same as the type of number you're going to end with. So if I'm adding two real numbers, then I'm going to end with a real number. If I'm multiplying two real numbers, I'm going to end with a real number. And it can go all the way back to if I'm adding two integers, your result is an integer. And that's your closure property, that you end with the same type of numbers that you started with. Next up is the commutative property, and the commutative property is that your order can change. So you might jot a quick note there. Commutative property, order can change. Associative property, I always say you're going to associate it with parentheses. It has to have parentheses, but don't be confused because other ones can have parentheses. But the main thing with associative property is notice it goes A, B, C, A, B, C. The order of the numbers did not change, and that's important. The order of the numbers did not change. Identity, you can think about what can you add or multiply to a number and not change the number. So for adding, you can add a 0 and keep your number. And for multiplying, multiply by 1. Inverse is, well, kind of the opposite for addition, right? So A and negative A, those are opposites. So for addition, it's opposites. And for multiplication, A and 1 over A, those are reciprocals. I'm going to bring up those two words again here in a second, but opposites and reciprocals. And the last one is the distributive property, and notice it's not under a single column there because it has some of both. And I'm sure everybody is familiar with the distributive property, that we take the number outside and distribute it into whatever's in the parentheses, however many things are in the parentheses. Get you your answer there. So I know I just touched on these two, but I want to make sure that you had them down. So opposite is the exact same thing as additive inverse. They mean the same thing. So the opposite of A is negative A. So the opposite of 5 is negative 5. Or the opposite of negative 7 is positive 7. One way to look at them is they are equidistant from 0 on the number line. And for reciprocals, the reciprocal of 2 is a half. A formal definition would be if you multiply them together, you should get 1, so there'd be 2 over 2, which is 1. And we can say the opposite of 1/5 would be 5. Again, if you multiply those together, you would get 1. That's what I have for you today. We'll finish up in class. Have a good day.